Hi, everybody. Today I'm going to be going over your second lab, which is copper transformations. It's going to be much longer than your first lab, so strap in. And it's also going to be the first time you're actually going to be working with chemicals in this lab. So you are going to be synthesizing copper through two different methods. In one method, you're going to start with a liquid solution, and another method, you're going to start with a solid metal. And from there, you will be able to generate copper. So just to give a brief overview, we're going to have several transformation steps. So here we go from hexaqua copper, which is a blue liquid, to copper hydroxide, which is a blue precipitate. And you can see that this is also matches with, this is our PubChem database. You remember that from our reference exercise. And so this is our PubChem database for copper 2 hydroxide. And we can see if we come over here to the chemical and physical properties and click on that, and we scroll down, we'll see that this does mention that copper hydroxide is blue. We can use that at every step. We can verify each chemical based off of the color it is and also its texture. So you'll be generating your copper hydroxide, and then you'll generate a solid copper oxide. And this copper oxide, you're going to end up having to filter using filter paper. So in lab, we will go over how you can filter a solid. From there, you will take your filtered copper oxide, and you're going to turn it back into hexa aqua copper 2. And then we will generate copper from that. And your copper should be a brownish color. I'm sure many of you are familiar with that. And from there, we are going to dry it, and then we're going to weigh out how much dry copper you have isolated. For the next step, we're going to start off with solid copper sulfate, and you will resuspend that in water to make your hexa aqua copper 2. And from there, we're going to add some zinc to serve as a catalyst and add some acid. And we will scrape off, or copper will form on that zinc. And we will scrape that off and weigh out the copper formed through that method. So, two different experiments. And it's going to be very critical that every step you are taking pretty decent notes, because the first major thing you're going to be doing on this laboratory report is observations. So I'm going to go ahead and switch over to LabFlow. And after you've inserted your initial observations and the weight of each copper in each step, you are going to be asked again to write observations from each step. So if you wrote all of your observations up here, you can just copy and paste them again to right here. Something to note: steps 2 through 5, or steps 1 through 5, really, are part one, and steps 6 through 7 are part two of the experiment. So for part one, we are going to delete steps 6 and 7. For part two, we're going to delete steps 2 to 5 because we don't need those. But you will put your observations here. Make sure you are talking about physical observations and talking about things that may be happening at the molecular level. So make sure you're incorporating both of those things. So you'll do that for both part one and part two. Then in your discussion, you're going to talk about the main differences between method one and two. So talk about how the methods varied. What were the different starting materials? How did the techniques vary? Did you maybe get different amounts of material out of the two steps or the two procedures? So just talk about that. And part two is going to ask you to talk about both the safety and yield considerations that makes you favor one method over the other. So I want to emphasize it's both safety and yield. So which one was safer and which one yielded more? And then based off of those two things, which method do you prefer? There's not a right answer for which one do you prefer. It just needs backed up based off of the safety and yield considerations that you discuss. And the last thing is references. So this last week we went over how to format references. So you're going to be putting that into practice here. And as you can see, it's worth a lot of points for this lab report. So the first thing you have to do is you need to list values that can be found online that can back up your observations. So try and find some website that maybe mentions the color of the metals to prove that what you generated was actually copper 2 hydroxide at one point, or that what you actually generated was copper cupric oxide. So make sure to try and find a source You can use the same website multiple times so long as you are referencing different articles on that website or different articles in that journal. And once you've made a list of potential values or observations that you can relate to published values, you need to provide at least one citation, one example um, of a published value. And it can actually be one of the references you use in part two of your references section. So just reference the value here and cite it, and you can include that citation in part two as well. And so part two is that you need to provide three citations that could be used in this experiment to support your observations and your data. Notice you are allowed to use the lab manual as a reference, but only once. So you need at least two other good references that can back up data like the observations that you had. So try not to think too deeply about these two things. You don't need to be pulling obscure journal articles about synthesizing copper because you also won't find any about synthesizing copper. Just maybe think about the websites that we've used in our reference class and how they could potentially um, be used to back up your experimental data. If you have any troubles finding those, please contact me um, sooner rather than later. But that is your experiment for this week. So hope you all have a good day.